Okay, so this is quiz 3. As always, try it out on your own. And what this is our first real uh, homework or exercise, or what have you, where we're starting to get into the probability calculus and calculation is becoming important. But we're still, the key thing is the concepts involved. The concepts will then determine what calculation you use. So let's start with the first one for those who tried this out. An urn, remember an urn is just a container. There's 100 balls, 50 are white, 30 are green, 20 red. So that adds up to 100 balls total. You make one single random selection. Think of this like a bingo, one of those bingo pots, and there's a bunch of balls in there. You just randomly pick out one. One event is R, the ball picked is red, R for red. Another possibility is G, the ball picked is green. Now the question is R and G are either 1, 2, or 3. Well, let's think of each of the definitions. Independent means if one event occurs, there's no memory of it occurring in the past, right? There's no memory, it's random. Well, the key idea here is random, so that's one that might apply here. Let's think of now mutually exclusive. Well, mutually exclusive means if one occurs, the other one can't occur. Okay, so independent, even though random occurs here and in the wording, it doesn't really apply as such. The better fit in this case is mutually exclusive. Why? Because the idea is if one event occurs, the other one cannot occur at the same time. So if I pick an R, a red, I cannot at the same time get a green. It's very clearly in this case mutually exclusive. So this is the one you're going to want to apply. Okay. So for the first one, probably of R, well, that's easy. How many reds are there? There's 20. How many total balls? 100. So it'll be 20 out of 100. You can reduce that down to fractions, right? How do you guys do that? You guys should know that by now. 20 out of 100, which is 2 out of 10. You drop the zeros. 2 out of 10 reduces down to 1/5, right? Now G, probably at G, well, how many greens are there? 30. So 30 out of 100 is, you can do the rest. R and G. Now let's think this through. And remember, goes with multiplication, which goes in terms with independence. You can only multiply if they're independent. Well, are they independent? Is there any memory of G occurring once? I mean, if you say get G, is there any memory of that prior to the other one? Well, you'd have to force the definition. This is a tricky one because you actually have to conceptually think about this. What does this mean? What you're saying is you make one single draw. R and G. Can you get R and G at the same time? Can you get a red and a green ball at the same time for one draw? No, that's impossible. So if you just blindly went about multiplying these because you see and you think they're independent, that would be wrong. The probability here is 0 out of 100. Why? Because you can never have red and green at the same time. So this one's just 0. A little tricky, but it's a conceptual question. Next one, what's the probability of not R? Well, the opposite of what you had for R. So if this is 20 out of 100, then the remaining is 80 out of 100. R or G. Whenever you see or, you want to add, but in order to add, you have to first determine that they are mutually exclusive. And in fact, they are. We already talked about that earlier. So this reduces to the probability of R plus the probability of G, which then equals what you have above here, and then you can figure that out. Okay, let's move on now to 2. Consider when two fair die are cast or rolled, X and Y. One possibility for the first one is E, you get an even number, and for the second die, O, you get an odd number. E and O, getting an even number for the first die and an odd number for the second, are either 1 independent, 2 mutually exclusive, or 3 neither. Okay, so are they mutually exclusive? If you have one, does it mean you cannot have the other? No. So in this case, that definition is definitely out. Independent. Well, they're fair die. Well, if you remember what fairness means, it means there's what? There you go. So independence here is the one that counts because one roll of the die has no effect upon the other one. There's no memory. They're random events, right? So we can go ahead and calculate that. So E, um, and by the way, mutually exclusive, if you think fair includes that definition, we're talking about the events E and O here. So that's different. Not just the two fair die, but E and O in particular. And so in that case, the mutually exclusive is it's not at play. So for probability of E, what's the chances that your first die is an even number? Well, that's just 3 out of 6. There's 3 even numbers, 2, 4, 6. 6 total, so 3 out of 6. Likewise for O. E and O. Here's the one that gets a little bit more complex. So and you want to do multiplication. Can you? Well, first you have to establish that they're independent. Independent again means random or no memory. Does one die have any memory of the other die? Is there any influence of one die on the other? And the answer is pretty much no. So this is probability of E times the probability of O. You can multiply because they're independent events. And that's going to be what you have up here. And then not E will be just the opposite of what you got for this one right here. Yeah. Okay, the last one, 3. This one's a conceptual one and a bit tricky, and you have to think through them. You got a class of 100 students. 70 hate math, 50 dislike philosophy. Okay. If you add up 70 and 50, that's 120. That means there's overlap. If you got 100 students, 70 hate math, 50 dislike philosophy, that means there's an overlap of some who hate both, right? They hate math and dislike philosophy. You got 2 possible outcomes. Either D, the student dislikes philosophy, D for dislikes, or E, the student hates math. D and E are they 1, 2, or 3? Well, independence, okay, first off, let's do mutually exclusive. That's the easiest one. Mutually exclusive says if one occurs, the other one cannot occur. In Venn diagrammatic terms, that means if you drew the circles for D and E, there would be no overlap between them. They'd be separate circles. But we just talked about this. There's overlap. Because 70 and 50 adds up to 120, and there's only 100 students. There's overlap between some who fall into both categories. So mutually exclusive does not hold. They're not disjoint. They're not separated out. So 2 is gone. So now the question is, are they independent? Well, does one have no memory of the other? Is one randomized relative to the other? And that doesn't really make sense either, because D and E, it's not like a rolling of a die where one, or say a flipping of a coin, better yet, where one event has no relation to the previous event. Student who selected hates math may or may not have a relation to a student selected who dislikes philosophy. So the idea of there being no memory here doesn't really apply, even though a student is taken at random. Yeah. So in the definition of independence, you'd have to force it into this, and it doesn't really work. The answer here is actually 3, neither. For those who are confused as to why this is not independent, there's an expanded version of that I didn't ask in the quiz here. If you were given the probability for above, if probability of E or O, you would actually have to do an extended calculation, which we're going to cover later in the course. And if you were to claim they were independent on strictly mathematical grounds, you could show that you get answers that don't make sense. What I've tried to do here, instead of going that route, because I've tried it in the past and it doesn't always work, is just try to do this conceptually. All right? Independence says one event has no memory of the other event. But in this case, these don't look like they're related in that way. It's not like E has no memory or no relation to, if you don't like memory, no relation to this. Yeah? So independence doesn't really apply there. You'd have to force it, and it turns out if you force it, you're wrong. So the idea here is, when it's neither, the idea that we're getting at here in this 3 is to show you that not every event will either fall into category of either independence or mutually exclusive. There are sometimes events that fall into this. For the course's sake, we will focus mostly on these 2, but just be aware that there is this 3rd category where it's neither these 2. Okay, that's it for the quiz.